This video discusses operations on functions. The operations that we're going to be performing on functions are our four basic operations: add, subtract, multiply, divide. Starting with the sum function, f plus g of x is equal to f of x plus g of x. So when finding the sum function, you just take the two functions, add them together, clean it up however you can by combining like terms. Our difference function, f minus g of x, is f of x minus g of x. So we take the first function, subtract the second function. We'll have to distribute the negative into the second function and combine like terms. The product function, f times g of x, is f of x times g of x. So you're just going to multiply your two functions together. This may involve some kind of distributing and combining like terms. And lastly, our quotient function. This is where we are dividing our two functions. F divided by g of x is equal to f of x divided by g of x. Anytime we're dividing, though, we're always concerned about dividing by 0. We know we can't have a 0 in the denominator of a fraction. We know that we're not allowed to divide by 0. So we have the additional stipulation that g of x cannot be equal to 0. We can also identify the domains of these new functions. The domain of the sum, difference, and product function is all the same. It's the domain of f intersected with the domain of g. So basically, you just need to find the domain of the two functions involved and then intersect them. I think the easiest way to find the intersection is to draw them both on the same number line and then look for the overlap in the domain. The domain of the quotient function is the only one that's a little bit different. Since we're dividing by 0, that's still a concern for us as we're stating the domain. You'll notice the first portion is the same as the sum, difference, and product function. We have the domain of f intersected with the domain of g, but then that needs to also be intersected with the function we're dividing by not being equal to 0. So we're going to take the domain of f intersected with the domain of g, plus we need to exclude where g of x is equal to 0. So let's try an example. Let f of x be the square root of 2x plus 6, and g of x be equal to 3x plus 2. We want to find f plus g, f minus g, f times g, f divided by g, and state the domain of each function in interval notation. I like to find all the functions first and then go back and do the domains since they're so closely related. So let's start with our sum function, f plus g. Now this can be written just f plus g, or it can be rewritten f plus g of x. These two notations are exactly the same. But what we want to do with our thinking is then say, oh, well, I need to take f of x and just add it with g of x. So that'll be the square root of 2x plus 6 plus g of x, which is this whole thing, 3x plus 2. And then we want to simplify it any way that we can. We can drop the parentheses because there is an addition sign in front. That becomes the square root of 2x plus 6 plus 3x plus 2. Do we have any like terms to combine? No, we don't. So our sum function is the square root of 2x plus 6 plus 3x plus 2. On to our difference function. F minus g. Well, this is the same as f of x minus g of x. So we'll take our f of x, square root of 2x plus 6, and we want to subtract this whole thing, g of x, which is 3x plus 2. In order to drop the parentheses, because we have subtraction in front, we need to distribute that negative. We get the square root of 2x plus 6 minus 3x minus 2. We look to see if there are any like terms to combine. There are not. So here is our difference function. Moving on to product. F times g. And actually the multiplication dot is optional too. You might see this just smashed together fg like this. Our product function, we take f of x and we multiply it with g of x. Well, that'll be the square root of 2x plus 6 times 3x plus 2. To simplify, we can distribute. That'll give us 3x times the absolute value, times the square root of 2x plus 6 plus 2 times the square root of 2x plus 6. We look to see if we can simplify it further. We can't. Now, you may notice that those are like radicals, but if we combine like radicals, we're going to end up with what we had in the previous step, and we don't want that. So our product function is 3x times the square root of 2x plus 6 plus 2 times the square root of 2x plus 6. Lastly, we have our quotient function, f divided by g. Here we're going to take f of x and divide it by g of x. Well, that's the square root of 2x plus 6 divided by 3x plus 2. We look to see if we can simplify this. Well, I can't divide that binomial 3x plus 2 into that radical, so that's as simple as we can make it. But since we now have a variable in the denominator, we want to state what values of x must be excluded. To identify the values of x that must be excluded, remember that we set the denominator equal to 0, solve, and then that's what we exclude. When x is negative 2/3, it creates a 0 in the denominator, so we need to state that x cannot be equal to negative 2/3. So there's our quotient function. Now we're ready to talk about domains. The domain for the first three functions is exactly the same. The domain of f plus g is equal to the domain of f minus g, which is equal to the domain of f times g. They're all the same. So I'm just going to write it once. To find this domain, we need to intersect the domain of f with the domain of g. We need to do the work of finding those two individual domains and then intersect them. So let's start by finding the domain of f. F of x is equal to the square root of 2x plus 6. When finding the domain of a function with an even indexed radical, we always set the radicand greater than or equal to 0 and solve. 2x is greater than or equal to -6. Therefore, x is greater than or equal to -3. We need to find the domain of g. G of x is equal to 3x plus 2. Since we don't have a variable in the denominator of a fraction or under an even indexed radical, the domain here is all real numbers. Now we need to intersect those two. I like to draw them both on the same number line. First, we have x is greater than or equal to -3. So that's going to look like this on our number line. The domain of g is all real numbers. So that looks like this on the number line. And we want to intersect the two domains. Intersection is the overlap between the two, so we look for the overlap in shading. Our overlap in shading occurs from -3 on. So that's our domain for our sum, difference, and product function. Written in interval notation, including -3 to positive infinity. Now we need to think about the domain of our quotient function. The domain for the quotient function, we want the domain of f intersected with the domain of g, plus we need to exclude where g of x is equal to 0. We've already found the domain of f intersected with the domain of g. That's -3 to infinity. So the domain of f divided by g is going to be equal to -3 to infinity plus exclude where g of x is equal to 0. We've already found where g of x equals 0. That's what we did right here. So we know that the additional value that needs to be excluded is -2/3. So our domain is going to be -3 to infinity plus exclude x equals -2/3. Well, we want to write this in nice interval notation. I always like to put it on a number line to help me. I need to exclude -2/3. So I don't want -2/3. But then I also need this -3 to positive infinity. Which looks like this, but I need to exclude -2/3. So that means that we're going to go from -3 and then stop at -2/3 and then proceed on the other side of -2/3. Writing this in interval notation, the domain of f divided by g will be equal to -3 included to -2/3, and we're not including -2/3. And then we pick it up on the other side of -2/3 and go forever all the way to positive infinity. In our next example, we're going to be evaluating a sum and product function at a particular x value. Let f of x equal 7 minus x and g of x equal 1 over x minus 5. We want to find f plus g of 6 and f times g of -2. There's two different ways that you can approach these problems. You can either find the sum function first and then evaluate it at 6, but I think the easier way, if I want to find f plus g of 6, this is the same as f of 6 plus g of 6. So personally, I like to just evaluate each of the functions at 6 and then take those two answers and add them together. So to find f of 6, I'm just plugging 6 in. 7 minus 6 is 1. And now I'll find g of 6. So plugging 6 in, I'm going to get 1 over 6 minus 5. It's 1 over 1, which is 1. F of 6 is 1. G of 6 is also 1. So f of 6 plus g of 6 is going to be equal to 2. We have the same choice with the product function. To find f times g of -2, you could find the product function first and then evaluate it at -2. But I like to think of it as this is going to be f of -2 times g of -2. I'll find those two values and then multiply them together. Finding f of -2, it's going to be 7 minus a -2, which is 9. G of -2, it's going to be 1 over -2 minus 5, which is 1 over -7. So we're going to multiply 9 times -1/7. That gives us -9/7. So f times g of -2 is -9/7.